Good afternoon. Today I'm gonna tell you about the simple principle about semiconductor, and let's start. As you can see in this show, there is some conduction band and valence band and forbidden band and Fermi level. The valence band is filled with the lots of electron in 0 Kelvin, and the conduction band is filled with lots of hole in also in 0 Kelvin. And is the forbidden band has no states, so this gap is the empty space. And we have to know about the Fermi level. The Fermi level is the probability of electron exist is 50%. And we have to know the dopants. Basically, the silicon atoms bonded with use 4 electron and combined with neighbors. At the time, if we doping the group 5 element as a donor, it has 5 electron and the silicon has 4 electron. If donor and silicon combine this use 4 electron, there will be one left electron. At the time, this electron will be the free electron carrier. And if we define the group 3 element as a acceptor, it has the only 3 electron, so there will be left one there one hole. We call this hole, and we have to remember this principle. And next is the type of the semiconductor. If the Fermi level is the closer to conduction band, we can notice this is the N-type semiconductor. And if the Fermi level is close to valence band, we can notice this is the P-type semiconductor. And between this gap and this gap, compare this gap, we can notice what a donor or acceptor is more defined. So as you can, if we see this diagram, here is the and donor is more defined than acceptor. N-type semiconductor have electron more than hole, and P-type semiconductor have more lots of hole more than electron. And if we combine N-type semiconductor and P-type semiconductor, we call that PN junction, and we can explain that PN junction use these diagrams. We have to drawing the PN junction diagram, Fermi level constantly, because if the Fermi level in N-type and P-type semiconductor is not constantly, it means there will be the diffusion current. So we have to draw the Fermi level constantly. And after drawing the Fermi level constantly, we have to draw the N-type conduction band and N-type valence band and P-type conduction band and P-type valence band. And 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 one more thing is if the Fermi level is constantly, it means in this diode there's no bias situation. zero bias situation. And before I mentioned about this gap and this gap in here, we can notice which doping is more. And the difference between conduction band and Fermi level means the electron concentration, and the difference between valence band and Fermi level means the hole concentration. And we have to know the IV curve. We can draw the IV curve, and we set the x-axis is voltage and y-axis is current. As you can see in this curve, the current will increase exponentially with the voltage, because in forward bias the barrier is lower, so we can see the current increase exponentially with the board. And in reverse bias, the barrier is higher, so the current is not following with the board. Thank you for watching this video.